these type of problems are designed to work, okay? In other words, if this is going to evaluate, if this square root of these this product of these two massive numbers plus this perfect square, if it's going to evaluate to a natural number, it has to be in a particular form. And that form would be something to this level right here. Let's say x, we'll do x minus, say a, or x minus k, whatever letters you want to use, it doesn't make any difference. And k is just an integer. K is just an integer. All right. Okay. If we can re-express this radicand, if we can express this entire radicand to be equal to something in this form, the answer simplifies greatly. And that's exactly what we did right here. Now, if you don't think about symmetry, a fairly straightforward approach is just to let a equal to the smaller value, and notice that this number right here differs from this number by 12. Again, was that 3,215,638 plus 12 would be 3,215,650. Okay, and of course the thing is designed to work. It's designed to work. If you didn't have the right numbers in the right places, it would evaluate to an irrational number. So, but anyway, here's the work. I rewrote the original expression. In this fashion right here using the substitution variables. And notice that it does work out nicely. It ends up being a perfect square binomial. Okay, it ends up being a perfect square binomial. Again, if this were 35, that wouldn't happen. And so you have to pay attention to the difference between these two numbers. Half of that squared has to be right there. And that's just because of the result a plus 6 quantity squared, the way it works out. It's the familiar identity a plus b quantity squared is equal to a squared plus 2ab plus b squared. I hope I put that on the screen for you guys. All right. And so you see, folks, if you noticed, see, really, this is just a parabola, and k can be a positive or a negative integer. So this is just a parabola. Let's say if k is a negative integer, it'd be a parabola that looked like this. That looks almost like absolute value, doesn't it? You know, if k were positive, it would be a parabola, you know, over on the other side. Okay, but you do have the symmetry, which means you can just pick the middle number between the arithmetic mean of this number and this number is actually 3,215,644. So again, if you recognize the form, this problem is trivial. You just say symmetry prevails, and each of these parabolas have, you know, axis of symmetry. You know, if k is positive, you could call this k right here, and you have an axis of symmetry of x equals k. Axis, this would be minus k over here, right? Minus k over there. And again, we're assuming that k is positive, just so the signs will take care of themselves. So, and again, this x equals k is referred to as the axis of symmetry. And when you hear people bantering about symmetry, that's exactly what they're talking about. Now, this is just a special case of a parabola, but x equals k is called the axis of symmetry. And so if you get any kind of symmetry going on, you usually can exploit it for an easy solution to these type of problems. Axis of symmetry. Okay, folks, now, so that's all. If you don't like the stuff about symmetry, you can just try what I try and notice that you get a perfect square binomial, and the answer just follows immediately. So again, this green value right here is the solution to the problem. Hope you enjoy it.